name's Bryce. I'm in EC 312, 332, however, I'm not in 342, and today I'll be going over the knowledge integration number 5. We'll be covering some of the low noise amplification, the use of mixers, amplifiers, filters, and local oscillators in the following transmission circuit. As you can see here, this is a schematic of the transmission channel, which is actually the bottom half of what was in KI4, with a lot of the same principles behind it. And as you can see, there's an antenna that feeds into a duplexer, that feeds into a bandpass filter, a low noise amplifier, another mixer, an amplifier, and then a low pass filter. So today we'll be covering kind of what each one of those does and how it modifies the incoming signal and manipulates it for the system. So a little background information on the high pass and low pass filters is a low pass filter passes through all the frequencies below a certain frequency, a certain cutoff frequency. High pass frequency passes all of the frequencies that are above certain frequencies, and when you combine them together, you get what's called a band pass filter that has a lower cutoff frequency and an upper cutoff frequency. And depending on how strict you want that cutoff frequency region to be, you can make it extremely strict to where it allows plus or minus 100 hertz at your cutoff frequency, or you could allow it to pass up to a kilohertz at those frequencies, depending on how strict you want to be on it. However, the tighter the band pass filter is, you'll use more power, it causes the filter to be slower, and there's pros and cons to both of it. Now, here's a description of those individual parts of the schematic that was mentioned above. So you have the antenna that collects the signal, and then it passes it down through the duplexer, and it sits at the bandpass filter. Now, the object of the bandpass filter is to reduce different frequencies. So for example, if you have a car radio, you're picking up all these different frequencies, but you want to tune into one specific channel, then you're using a bandpass filter to filter out all the frequencies that you do not want, and then to hone in on the one frequency you do want. Now, this can be used with various op amps and transistors that will minimize the various frequencies around this. Now, in testing, right after the bandpass filter, or prior to the bandpass filter, we'll add in noise, because in everyday environments, there's constant noise, whether it's from the antenna, from Mother Nature. So in testing, noise is added before a bandpass filter that allows you to also mock how tight you want your bandpass filter to be for eliminating noise. After that, it's then passed through a low noise amplifier, which amplifies the bandwidth and the phase, as well as increases the stability of the signal itself, which can be good for if you have a kind of an inconsistent frequency or an inconsistent signal. After that, then you demodulate the signal, which means you multiply it by a cosine omega CT, which then splits it up and pushes part of the signal to the baseband. Now, attached to the demodulator is a carrier signal, which is used with a local oscillator that allows the carrier signal to be added into the signal to maintain the same phase. Therefore, you are on the same page as whatever system you're receiving the signal from. So let's say from a satellite or an antenna that's broadcasting that signal. Now, after it's demodulated, it is passed to another amplifier. However, this is a baseband amplifier that amplifies the bandwidth and the phase of the baseband signal, which we just demodulated, as well as increases the stability. Now, after the baseband amplifier, it's passed through a low-pass filter, which is used to reduce as much noise as possible and really focus in on the signal that's just around the baseband, which means eliminating the extra frequencies out at your omega C and negative omega C values, because signals in theory have both occur at both positive and negative frequencies, so a positive 1K and a negative 1 kilohertz. And then once it has passed the low pass filter, then it's put into whatever system. So for your car radio, that would be the last step, and then after that, it'd go through whatever kind of amplifiers for your speakers and whatnot, and then you would hear the sound. So overall, this is a very practical and a very useful system. It's commonly found in phones, as well as any other devices that have antennas. So car antennas, your garage clicker antenna, anything that has an antenna will follow a generic guideline or template of this manner. And thank you for listening.